Hi, I'm Bharat Balagopal. I'm a postdoctoral research scholar at North Carolina State University in the ECE department. The Advanced Diagnosis, Automation and Control Lab, or the ADAC Lab, was founded and is directed by Dr. Mo-Young Chow, a professor in the ECE department. The ADAC Lab works on control, robotics, and mechatronics and apply these concepts into modern and futuristic applications like smart grids, nuclear reactors, and robotics, and other instrumentation-related areas which are gaining a lot of interest. This lab here focuses on the smart city concept and control of unmanned vehicles. So as you can see here, we have a number of unmanned vehicles that are going to be traversing this path, and then we have renewable energy resources like solar panels, wind turbines, and batteries that provide energy to the charging stations where the unmanned vehicles go to charge themselves. And here we even have a user interface that can simulate and visualize how these unmanned vehicles behave. And all of this is done using these 8 infrared cameras that act as an indoor GPS system. They're able to detect the position of the unmanned vehicle anywhere on this track. The main purpose of this lab was to teach and motivate students to fall in love with the concept of control. A lot of people know about robotics and mechatronics, but control is the background which makes robotics and mechatronics work. So we wanted students to learn about it, get motivated to work on these areas, and of course perform research to develop new technologies that can assist everyday life. And of course giving students a hands-on experience on working on these kind of research areas. So we have hardware, we have software, so they can explore their interests in our lab, in control, robotics, and mechatronics. What we develop in our lab doesn't just stay there. We want to take it from the lab into the real world and make a difference. So the most rewarding aspect of my work as well, working with my advisor and my team, because we work so cohesively. So Dr. Chow, as an advisor, he's amazing, and he's able to always lead students and researchers in the direction they're interested in. So we get together and they present their ideas, we present our ideas to understand, so this is what you're doing, this is what the other person is doing. And then, we brainstorm and we collaborate. So that kind of exposure, that kind of working together helped me understand, so this is the focus of the lab, this is the direction we want to go in. And instead of, me just talking to him and focusing on my area, I was able to broaden my horizon because we work together as a team. We have 2 main technologies that we've been working on for over a decade, like almost 15 years right now. One is a smart battery gauge. This one is mainly focused on battery and energy storage research. So here we have battery simulator, which can simulate the operation of a battery. We've applied that concept to electric vehicles. So here you can see the electric vehicle simulator with the hardware actually there, where the hardware communicates to this user interface, and you can see like a heads-up display as the vehicle goes faster and slower, your charge changes, it has your navigation, all of that. We've taken it one step further to integrate our battery technology into the smart microgrid, to integrate renewable energy devices that would in the future be in the iSpace lab, as we saw previously. And we've also been working on nuclear reactors. So we've been developing smart instrumentation, intelligent instrumentation to integrate into nuclear reactor. So this small setup over here is a tank that simulates the vessel of a nuclear reactor on a very small scale, where we integrate the different sensors that we want to study and communicate with them on a remote monitoring interface to say, okay, what's going on in different sensors, how do we control it? So using distributed sensors, they're collaboratively making a decision, working together collaboratively, distributed, and making a decision. And we've been able to develop this technology from lab prototyping to real-world testing. So we've been able to take it out into the real world, test and validate that it works, and now we're trying to commercialize that technology, which is The whole point of engineering, in my opinion, is to take something from the lab and make it usable by people. Our lab, the Advanced Diagnosis, Automation and Control, or ADAC Lab, directed by Dr. Moyan Chow, it's a lab that fosters creativity and innovation. We do not put restrictions on how people can think. And very often the only thing that we talk about is why. That one question that we ask ourselves, why are we doing this? Why does it happen this way? That motivates us to keep on working. So if you're interested in being part of a team that's working on futuristic technologies and is ready to take on the challenges of the new world, come join us and be part of our revolution.